Right, good day and welcome to learning exercise 3.1 patterns. Now there's just some guidelines to understanding linear pattern problems. Right, you can pause and read through it. Right, you must be able to find common difference, determine next two terms, must be able to determine a general term using Tn equal a plus n minus 1. Use your formula to find either value of say 15 term or which term equals 50. Use the common difference formula to find the value of an unknown variable. Alright? Note, n can never be negative. It must be an element of natural numbers. So number one, I'm looking at linear patterns with positive common difference. So we consider the arithmetic sequence given 2, 5, 8 and 11. First question, can we find the common difference in the next two terms? So common difference, t equals term 2 minus term 1. So there's term 2 minus term 1. They said arithmetic sequence. So 5 minus 2 gives me 3. Or I could say term 3 minus term 2, 8 minus 5 gives me 3. Or I could even say term 4 minus term 3, which also gives me 3. So to determine or find the common difference, I have next two terms. If I continue adding 3, 11 plus 3, 14. 14 plus 3, 17. Or term 5 is 14, term 6, 17. 1.2. Now this process we have to get used to. So I make use of Tn equals Tn plus C, where T represents my common difference and C basically represents the point where we will cut the y-axis. Right, so T there, 3. So Tn equals 3n plus C. So in place of T I substituted 3. Right, now if I choose term 1, so n becomes 1, that n also becomes 1. Right, now what's the value of term 1? You see that term 1 is 2. So instead of writing term 1, I write 2. 3 times 1 gives me 3, plus C. If I take 3 across, it becomes negative. Negative 3 plus 2 becomes minus 1. C is minus 1, therefore Tn equals 3n minus 1. Alright, hope you follow. 1.3, so that 1.2 determine a formula. 1.3 determine a value of the 12th term. So that we always ask after you've found your formula. So Tn equals 3n minus 1. Therefore term 12 equals 3. N now is 12. 3 times 12 minus 1, 36 minus 1 gives me 35. So there's my term 12. So these are linear patterns with a positive common difference. We go to linear patterns with a negative common difference, meaning the sequence actually decreases. So if you look at the linear pattern, 7 minus 4 is 3, 3 minus 1 gives me minus 1, minus 1 minus 4 gives me minus 5. So again, they want next two terms, general term, value of the night term, which term equals that, and is 109 a term in the sequence. So get common difference, linear pattern or arithmetic sequence, same thing. Term 2 minus term 1, 3 minus 7 equal minus 4. So my next two terms, minus 5 minus 4, minus 9. Minus 9 minus 4, minus 30. 2.2 to get the general term. Again, linear pattern, Tn equals Tn plus C. So term 1, my t value there, as you can see, is minus 4, so I substituted t minus 4. If I write t1, n changed to 1, therefore that n also becomes 1. Right, minus 4 plus c. Term 1 equal to 7, as you can see first term. So then instead of writing term 1, I write 7. That is minus 4, if I take it over, become plus 4. So c 7 plus 4, c equals 11. So my equation, Tn equal minus 4n plus 11. Right? Next question, determine the value of the 9th term. So determine the value of the 9th term in 2.3. I have Tn minus 4n plus 11. That's the equation I found. So term 9 equal minus 4 times 9 plus 11. Minus 36 plus 11, minus 25. Right? Question 4. So we just read there which term is equal to minus 65. So there's my equation. Tn is minus 4n plus 11. Now then I want to know which term is minus 65. So the whole Tn becomes minus 65. Minus 4n plus 11. If I take 11 across, 65 plus 11 gives me negative 65. It's 4n, and if I divide, I get 19. N equal to 19. So take note, n always positive. 2.5 is 109, a term in the sequence. So we come across here. Again, Tn becomes negative 109. Take 11 across, negative 120. If we divide by 4, n equal a positive natural number, 13. So n is an element of natural numbers. Therefore, Tn equal minus 109 is valid. I hope you understand. This is part 1. Part 2, we will be looking at rational numbers and when unknowns are given. Thank you. Bye.